Welcome and thank you for joining us for this technical session. If you'd like to track your session attendance in the CVent app, the check-in code for this session is displayed here on that paper. Please note that this code will only work for 15 minutes before the session starts until the session ends. Further directions on tracking course attendance are available in the CVent app under the IHEEP 2023 event or in your printed program. This session is scheduled from 11 a.m. until noon. Your speakers for this session are Richard Manser, Greg Faber, and Jacob Temuga. Mr. Manser advocates for improving public right-of-way utility data management through policy-driven technology. Mr. Manser is a registered professional engineer and a member of the American Society of Civil Engineers. He helped write the standard guideline for recording and exchanging utility infrastructure data. Mr. Manser is a member of the Transportation Research Board's Utility Committee and an affiliate member of the American Association of State Highway Transportation Officials Committee of Right-of-Way, Utilities, and Outdoor Advertising. He served on the National Strategic Highway Research Program Implementation Team for several utility projects. Mr. Manser served as the statewide utilities engineer for the Utah Department of Transportation. During his tenure, Federal Highway Administration recognized UDOT with 2 national awards, Excellence in Utility Program Leadership and Building Consensus Through Collaboration. Greg works as a Deputy Director, Right-of-Way Division at Texas Department of Transportation. Jacob works as a Director of Digital Delivery at TxDOT.
Thank you for the introduction. So we're here today to talk about integration of 3D utility data. And so one of the ways that we're working with Jacob and his team with the digital delivery effort at TxDOT is to create a new permitting system, utility permitting system. So what we've called that utility permitting system is RULIS. You'll see that throughout the presentation. RULIS is right-of-way, utility, and leasing information system. So, we at the DOTs love our acronyms, and that is just one of the many acronyms that we have. So that's on, but I'm not advancing the slide. Hitting the space bar and nothing's happening. Richard, this is your computer. I'm going to have to ask you to. That wasn't the screen we were looking at earlier.
Working. All right, let's close it out. Reload it.
Technical conference, technical difficulties. There we go. So one of the ways that, as we were developing kind of the purchase order for RULIS, the right-of-way utility leasing information system, was we're looking for a return on investment. So in the slides, I'll show you kind of what we had before and the direction that we're headed, who our customers are. So to give you an idea, in Texas, in our previous system, which was the utility installation review, there were 30,000 users over the 16-year lifespan. Over 350,000 permits were submitted. So on a per year basis, we're looking at anywhere from 25,000 to 30,000 permits a year, utility permits within the right-of-way. Understanding the development of this project and working with Jacob's team, we understood that we had to be flexible, that there are a lot of moving parts, and as you go through this conference, you see all these vendors, right, that have different technologies that are ever-changing, so we know that we have to remain flexible. We've got to give our districts the right tools in order to deliver the project, so we'll talk a little bit about that and the communication. So why is RULIS important? So I've got annual budgets up here, and I want to take a moment to just talk about TxDOT's budget. So we have what's called a Unified Transportation Plan, UTP is what we call it. And over the next 10 years, we're going to do $100 billion worth of transportation projects. That's just construction dollars and maintenance. If you look at it from a global level of project development and things like that, it's $142 billion over the next 10 years. So we've got a lot of money, we've got a lot of projects, we've got a lot of moving parts. So we've got to have these innovative solutions to try to deliver on that. Talking about annual budget, fiscal year 24 for right-of-way is $1.5 billion. So that includes our acquisition and utility adjustments. So we're averaging over the last 5 years about $350 million in utility adjustments per year. We're buying about $900 million to $1 billion in right-of-way. So just to give you a little bit of perspective on what we're doing. Subsurface utility engineering, so the SUE, as many of you know it by, and utility coordination and utility engineering contracts that we have, $70 billion is what we're spending on those. We just created a new function code for utility coordination, so we're able to extract the amount that we're spending on utility coordination. Right now, we really don't know that number. We kind of lump it all together with subsurface utility engineering, utility coordination, and utility engineering. So our Transportation Commission has asked us to execute, and they say execute, execute, execute. So we have to continue turning dirt, continue on our project delivery process, and we've got to look for ways where we can reduce costs, maximize effectiveness and efficiencies, and that's what this system was built to do. So, as we're improving our utility management, Richard, this is actually, I think, an older version of the presentation. But that's okay. I'll roll with it. So improving the utility management, the right-of-way leasing system. So our predecessor was the UIR, Utility Installation Review. And what a utility company would do was they would drop a lat long on a permitting system and say, this is where the utility adjustment begins and no other geospatial data. So we have a bunch of, if you have a longitudinal fiber optic line that's going for miles and miles, we had one point of data where that was. And so the new system, one of the accomplishments that we have is that it's a GIS-based system. So the utility companies are physically drawing in where their facilities will be on the right-of-way. We ask a lot of questions during the permitting process. I think we increased the number of questions that we asked from anywhere from like 25 or 30 to close to 50 questions. So we're getting more data on where those utilities are. The next steps of the RULIS project are we're going to be doing conflict management within the RULIS system. So you'll actually be, districts will be managing their conflicts with utilities on projects within the system. We'll also have a utility agreement and utility payment portion of it where we can track better where agreements are in the process and where utility payments. So one of the big pinch points we have in Texas is getting utilities to bill us, and I'm sure a lot of other state DOTs have that issue too. So we're trying to come up with ways to better track those things. And so we're hoping that return on investment of the increased data that we get from the RULIS system will help us better deliver projects. So right now, one of the big gaps that we have in the old system was we weren't capturing any as-built data or after-the-fact data. So we would have plans. We all know plans can go good and they can go bad. So any sort of red line adjustments in our previous system, we were maybe picking up 1 in 1,000, just to give you some perspective. We may get an as-built 1 in 1,000 permits. So what we're hoping in this new system, and I'll talk in a little bit about how we've changed our utility accommodation rules to tie the as-built deliverable into a statute to kind of give us some more teeth when we're talking to utility companies and saying, hey, we really need this data. So to capture that, we have the day-to-day permitting, the encroachments. That's really where the big gap is. So you've got AT&T going out there, and I'm just picking on AT&T because they're a huge company. They're going out there and they're putting infrastructure in our right-of-way that's not related to a transportation project. That's where we have a huge gap in capturing our as-built data is AT&T's not submitting any as-built data after they go put their infrastructure in. Prior to project letting, we're probably a little bit better at that, and that's something that'll play into the digital delivery effort, quite a bit. Is we have our SUE providers, we can scope in to our SUE deliverables some as-built data. So as the utilities are adjusting, we have TxDOT contract forces out there capturing that data, uploading it and putting it into our plans. And then we have after project letting, TxDOT has a solution for, you know, municipalities and other utilities to be joint bid as part of the PS&E package. And so we're usually, and I say usually, getting pretty good data on those as-builts as well. Another gap that we identified is our inspection resources. So TxDOT is a 13,000 person organization, but the folks who are doing the inspections for utilities in our maintenance office number at about anywhere from 50 to 75 people. So if we're getting 125 permits a day, we're getting 30,000 permits a year, we've got 50 to 75 people managing doing those physical inspections of the right-of-way. So we have a huge gap there. So what we do is we lean on our consultant forces. We have CE&I in our contracts and our construction projects, and that for fiscal year 23 exceeded what we paid for in PS&E. So we're paying more in CE&I to make sure that what we're doing in the field more than what we're doing, paying more than what we're paying for PS&E. And again, reiterating that point on the fourth bullet is the gap is largely encroachment installations, so a utility filing for a permit and not related to a TxDOT project. And we get out there and they say, hey, we're 48 inches deep here. And our contractor gets out there and they're 30 and they're, you know, in the way of the transportation infrastructure. So the UAR, which is the Utility Accommodation Rules, we worked on updating those. That was a 3-year process. Obviously, the utility companies have a lot more lobbying power than TxDOT, which has 0 lobbying power. But you know, there was a lot of back and forth on those utility accommodation rules. We were trying to get depths to be lower so we can avoid, when we're doing maintenance activities and things like that, avoid utilities. There was quite a bit of pushback from the industries on, you know, hey, if we have to go lower, that's more expensive for us. Well, think about it in the long run. If we avoid you in the future, you won't have to pay a relocation cost. So, you know, trying to get them to see those wins. So RULIS, you know, this first phase of it that we released July 24th, 2023 is the utility permitting and as-built repository. So that's really where, you know, for the last, 2-3 months, we've been delving in. We have Ricardo here with the project team on our consultant side. How many permits did you say we've had submitted in those 2.5 months? 5,000 or 6,000 permits in the last couple months. So I mean, just to give you an idea of what's going on. So we replaced the UIR. This is a web-based, so you can actually access the RULIS system on a tablet or your phone. You could not do that with our previous system. You could only use Internet Explorer, which was rapidly declining, and we were basically using duct tape to make the old system work, so we really had to deliver a new system. Then we had to integrate with all these systems, TxDOT Connect, which is our, you know, system of record, you know, having integration. I'll get a little bit more into that as we talk about the application that we developed. So flexibility during implementation, again, this is something crucial and that Jacob and I hit on in just about every meeting we're in, is we've got to be flexible because things are going to change. Right now, utilities, the utility section is probably, you know, I keep telling Jacob we're ready to jump off the diving board into this, you know, kind of digital delivery world. And, you know, Jacob's team is trying to get everybody else on board moving that ship. So I'd say utilities are, you know, pretty far in advance. I think Jacob would agree with me on that, and that we're really trying to deliver, you know, the proper information that's going to be needed for that digital delivery effort. So, you know, that hits into changing environments, communication with the industries. So we've got to change things contractually now. For you know, some of our SUE partners on the deliverables that we get from them. I'd mentioned we spend $70 million in subsurface utility engineering. Right now we don't have a data repository for that. So that information right now is on CDs or on hard drives. There's no central repository for that information. So another component of the RULIS project is developing that repository where a district gets a SUE done on a project, and a deliverable from that SUE will be an upload of a file to the RULIS system. So we'll start, you know, gaining some traction on keeping track of the information that we're paying $70 million a year for. So some of the tools, we've changed our policies and requirements. I talked about changing the UAR. We've tied the ASCE 7522, which Richard will talk about here in a moment, and the ASC 3822, which is the kind of the SU standard. We've tied those into our statutes. The second bullet here is data standards. What that means to me is we had to work through many, many meetings, Richard, Ricardo, and I, and the team, on what does our feature codes look like. So we want what our contractors are shooting in the field to be able to go into the digital environment and be able to be spit out into a data repository. So right now at TxDOT, we've probably got 5 or 6 different versions of that feature code class that our consultants are using. We need to have one central feature code class that they're using out on the right of way. Engineering requirements and construction contract requirements, those fall into what we call, our PEPs, our Professional Engineering Services Division. So we're working with them to rewrite the scopes of work for our engineering requirements and our construction contract requirements to get the deliverables that we need to upload to the system. So one of the big gaps that I mentioned is inspections. Part of the Rulus project is also an inspection field app, and the next couple slides will show you some screenshots from that app. But basically what we're trying to do is supply the tools and the tool belts of those 50 to 75 inspectors when they go out and do those utility inspections. Rather than doing a paper form, which they're doing now, they're actually putting this in an app, and it's talking with the system and tied to that utility permit. So they can take pictures of changes, they can take pictures of the right-of-way to make sure that within the different stages of the utility process for that installation, that's going correctly. So you can see the available actions are utility not on site, or utility installations in progress, or the utility is mobilized. So you can click these different features and questions will come up kind of as the next screen to say, is the traffic control compliant? Safety is a huge issue, a lot of times something that's lacking from utility companies working on the side of the right-of-way is their traffic control, right? And then, is all equipment and materials outside of the clear zone. Are they compliant with their plans and permits? So, it's easy questions that folks can answer out in the right-of-way while they're engaging with the contractor who's moving. A big one there is compliant with the UAR, which is Utility Accommodation Rules. We have the ability to have comments entered into this inspection app, and the great thing is about the comments on the top line is those can be sent directly to the utility company. So if there's an issue, we can start communicating with the utility company while we have boots on the ground that there are issues. We also have a line for internal comments, so it might be something like, hey, this utility is doing something incorrectly, we need to make sure we get as-builts from them. Again, kind of another picture of the checklist. A great component of this is you can also take pictures of the traffic control or anything else, and you can make comments, and that all uploads to the utility permit and is saved as part of that final file with the utility permit. There's also the stop construction. So if a utility is doing something really wrong, we can stop construction, and when we press that button in the app, the person who submitted the permit immediately gets notified that there's a stop work on this for the reasons that it stopped. Entering completion dates. So this is something where we have a system called TxDOT Connect. What we've had a lot of trouble with, and what we're getting asked from our administration is, hey, when is that utility going to start, and when did they finish? So now we've made it mandatory for utility companies to put in their actual starting dates, and that integrates with our system, TxDOT Connect. So as we're pulling dashboards and information about project readiness or the risks to projects, we're able to see when they started work, when they ended work, and that way we can better develop our letting schedules and things like that. Again, one of the big gaps that we identified and that we wanted to correct in the system is being able to upload utility as-builts. And so now utility companies have the option to upload a CSV file or a shape file. So when we were talking to utility companies, we were asking, what can you export out of the systems that you have? Those seem to be the two that were the most prolific. We don't have PDF there because PDF really doesn't do us much good on the system, and so we've allowed for the utility to go back into their design also, where they can modify the design if they've made any changes for what they're drawing, if they're drawing the file within the system. So that's a little bit about our ruleless system. I know that was a lot of information. I hope I didn't go too long or speak too fast, okay, I got thumbs up, so that's good. I'll pass it next to Richard Manser to talk about data management.
Okay, I'm going to talk to you a little bit about data management, specifically with how TxDOT has been implementing their systems. And first of all, I want to talk about this ASCE 75 standard a little bit. This is an engineering standard. It's a new standard. It was just released last year, as Greg mentioned, and it was developed as an open standard. And open standards are pretty important, pretty critical if you're going to be sharing data between systems or between other agencies or whatever. Let's talk what's included in the standard. Features, attributes, location. I'm going to have to reload this, Greg, so you want to take some questions?
Sure. Does anybody have any questions on what I've presented?
You said at the beginning that in the new system they can draw their utilities in. Is that the CSV shapefile upload?
No, so that's not an upload. That's actually where they're physically in the system drawing in where
So I
they're.
was wondering, so
Yeah.
what is that? Could you be more, I'm sorry, I can't imagine giving them a tool to draw. What does that look like? Like, is it a web interface they can
Yeah.
click in?
Yeah, it's kind of like a Google Earth, like if you were trying to draw, just a parcel out of a piece of land or something like that. It's very user-friendly. I would say people who have little to no technological experience. Now, I'm not saying my mom could do it. My mom is not very tech savvy, but folks in the workforce who mess with technologies every day would be able to pick it up pretty quickly.
Really cool stuff, yeah.
Yeah, thank you. We're really proud of that. They can also draw on their abandoned facilities, which isn't something I mentioned, but abandonment is a huge issue where we got a contractor who comes across a conduit. Is it live or is it not? Now the utility has the ability to draw in that abandoned facility.
I guess one follow-on, do you have a transactional space that this goes to, and then someone approves it and pulls it into a system of record? Or are you taking what somebody draws or uploads as correct until you hear otherwise?
So in our utility accommodation rules, it's on the utility company to upload the correct file. That's at their risk. And so that's something that we've had to work with, kind of risk balancing on the UAR changes, utility accommodation rule changes that I was saying, is we don't allow utility consultants. They can upload a file, but it has to be submitted by the utility company. And they're signing off and saying, hey, this is where we are, and we're confident in that. Did that answer your question?
It does. And I'm overcomplicating, but I think I would want somebody to make sure they've used the right data fields, attributes, that they haven't just uploaded garbage.
Yeah.
Otherwise, I'm getting a bunch of garbage in my system. So I was thinking you would need to put a stopgap there of somebody to, even if it was an FME server, to just check it and make sure that it's right. But that's adding steps.
Yeah, I'm getting some nods from Ricardo, so do you want to?
It is like that.
Yeah.
Yeah, it works like that. Basically, for the designs, we let them draw by hand or upload any data. We do verify the data they're uploading. We do have field codes. We have codes for all the fields that they can put in. Obviously for the ASBIL, they can only upload CSV or shape files or whatever format that we would let them KMZs or whatever that are certain particular projections. It depends if you're doing design or ASBIL. So ASBILs, we take everything. Design, we take everything. ASBILs, we're much more precise, and we ask for more mandatory fields.
Great question. Anybody else? Yeah.
I apologize if you've said this and I didn't catch it. Is the data publicly available, or is this for internal staff use and with the vendor partners you've got on the project?
Yeah, so if I'm AT&T, I can't see what Verizon's putting in. So you only see the permits that your company submits.
Okay.
Yeah.
And then no public actually sees it. It's
So we're
information
working,
staff.
we're working on, we have what's called a project tracker map that has quite a few, probably has 100 layers of, GIS layers that is public interfacing, and we're working on exporting minimal information out to that map so folks can see. But again, utility companies say everything's confidential and I don't want people knowing where my facilities are. So we still have a few of those battles to go through. Yeah. Good question. Richard's back.
We're back.
Okay.
Cross your fingers. Okay, I talked a little bit about this standard. It's a national consensus standard. It was developed over a period of over 7 years with a lot of multidiscipline people on that committee. And I had the opportunity to participate actively in a lot of the development of the standard. So that was very eye-opening and rewarding for me. It's harmonized with the ASCE 38 standard, which has been around since 2002. This means that the definitions are the same between the standards, and they've eliminated any overlap between the two standards. Lastly, it's not a procedural or an equipment standard. This does not tell you how or what equipment to use when you do surveying. It's strictly a data standard. I'm going to talk a little bit about what's included in it. There's 5 different topics here I want to discuss with you. Feature types. This is not a complete list. I think there's 7 feature types, but these are the most familiar, the most common ones that are in the system. Segment is a linear feature type. Some examples would be a gas line, a water line. It's a series of connected points. A device is not a linear feature, so it's something that's discrete, that's directly a part of the utility, like a valve or a transformer. Access point, these last ones are kind of intuitive. It's a point where you can access the utility, a cover, a door, that sort of thing. Support structures, something that's used to support the utility line or a device, a pole, a thrust block, and a containing structure, something that houses or provides access to those, a pole box or a valve box. Attributes actually define and describe each of those utility feature groups that we just talked about. They vary by the feature type. There are domain values associated with each of those attributes in the standard itself. And the users can add additional attributes if they want to. The only caveat is you don't duplicate something that's already defined in the standard itself. Here's an example. These are made up data just for fun. Each record requires a unique ID number associated with it. And this ID number and the owner, these are attributes that can be defined. The domain values for these attributes can be defined by the owner of the system. So if it's TxDOT, for example, they've got a list of who their utility owners are, and they'll define that in their system. These next 4 attributes are part of the standard. So these values you see here were picked from a list within the standard, potable water, distribution, pressurized underground. Okay, location. These attributes are critical to the standard. Standard reference datums are required, and that's critical if you're going to exchange data with other systems or other organizations. So if you're using a local reference system to do your surveying, it's required to convert that to a standard definition. ASCE defines attributes for relative survey points. These are points that are taken on different positions of the feature, such as the top of the pipe, the invert, maybe the outside corner of a box. So when we're exchanging 3D object data, we actually do that using the centroid, that 3D object. In most cases, this has to be calculated from these other reference points that you're recording. So in order to get to this centroid, if you have a symmetrical object, whether it's in 2D or 3D, that's fairly easy to do. If it's a circular pipe, for example, it's the center of that circle. If you have an asymmetrical shape, you could use a combination of symmetrical objects to define that, or you can use the shape would approximate the maximum space that's used by that particular device. And a good example, I don't know if you can see it in here, but there's some manholes that have an offset cover on those. You could use a cylinder that covered the entire volume of that installation as an approximation. We've seen a lot of new technology introduced in the last 10 years or so, LiDAR and even handheld photogrammetry and things now, which have really given us a rich set of data with which to describe utility features. It's also given us a large set of data to describe utility feature. These point clouds can be huge. To my knowledge, we do not yet have a standard on how to deal with these point clouds. But I do look forward to some advances in technology that will give us some standardization that will simplify these data sets and automate that process as much as possible. Accuracy in the standard is defined in 6 different levels. The highest level of accuracy is 1/10 of a foot, and you're required to record accuracy for both the horizontal and the vertical components of your location. And they may be different. In a lot of cases, they are different. While the standard was designed for utilities in every installation situation, there is a strong focus on things that are buried or submerged. The maximum interval between survey points on linear features is directly related to the desired accuracy for, I messed that up. Anyway, what I want to say is if you want more accuracy, you have to take more points. Your intervals have to be shorter. If you have straight lines or if you have rigid materials, you obviously don't need as many points because your deflection is much lower. You can approximate curved alignments by using chord shots. And again, the accuracy of your data now is dependent upon the length of those chord shots. So if you want more accurate data, you need, again, more points and shorter chords. The standard does include examples of how to do trenchless installation. Typically, you're required to survey your entry and exit points on a trenchless installation. And there will be a drill in most cases that has a sonde on the tip of that drill that emits an electromagnetic signal, which can be recorded at the surface. As you're going, your boring machine has a record of depth based on the angle and positioning of that machine from the entrance point. And so what you can do is you collect those sound readings on the surface at your interval you want to collect on and mark those points. And then you take the boring log information for depth and match it up to your surveys of those points on the surface, which gives you a pretty good position in most cases. As we mentioned previously, the standard is for data. It's not for anything else, and this is probably pretty critical. It's not for rendering. So when you talk about CAD attributes of line weights or patterns, colors, all of those things are not in the standard. It's important to know, however, that the standard does have enough information that when you bring that data into your other system, if it's a CAD system, for example, you can create those attributes in your working space. So if it's a gas line and I want to show it as a yellow line on the map, because that's the color coding for gas, then you can make that conversion in your other system. It does not address CAD objects because CAD systems are proprietary. Jacob may want to talk a little bit about efforts there. I know the industry is starting to develop some pretty more extensive libraries of 3D objects in the CAD, specifically for utilities. Switching gears, I want to talk about the importance of being able to exchange data with all users, all potential users of this data. So bidirectional means that we're we're receiving, and we're sending data between two or more systems. We're reading and writing those data. In our industry, in transportation, we have three groups here that play a pretty key role in both using and producing utility data: the supervisors, the utility owners, and the contractors. Each of them depends on utility records to be able to do their work. Supervisors, for example, use this utility as-built data as the basis to start their field investigations. And lastly, exchanging data with utilities and with contractors is considered a successful practice in the industry today. It's very important that your utility data be stored in a database, not spreadsheets or any other type of a system. This is important if you're going to be able to exchange data with other enterprise systems. And I think you can receive a pretty good return on investment if you're able to do that with these first four, with your CAD environment, with your GIS systems, permitting systems, and if you have a broadband system that you're using in your department. These last two, planning and maintenance, are primarily consumers of the information at this point. There may be an interest in an environmental study, for example, in knowing where those utilities are so you can avoid impacting them. And with that, I'm going to turn that over to Jacob.
Thank you, Richard. So, wanted to talk a little bit about the importance of utility data in digital contracts. You know, as you see around this conference, a lot of people, a lot of DOTs are moving towards digital delivery. So utilizing models in the field. And there's a lot of opportunities there for us to really create efficiencies, not just in design, not just in construction, but all the way around the project life cycle. So I just listed out a few things that, you know, for utilities, with what Greg and Richard have been doing, there's a lot of advantages to it. You know, whenever we have, say, a project that we don't know exactly where our utilities are, that's a risk, right? And so by being able to locate those by the information that's in the RULA system, we can accurately design around these utilities. We want to make sure that our goal is always to miss them first before relocating. We can streamline construction too. So, you know, finding utilities in the field happens a lot. And, you know, one of our mantras at TxDOT is every project is a safety project, right? And with us expanding that amount of construction by exposing people to the field conditions for longer than necessary, we really do increase that risk. And so we want to, you know, utilize this as a way to really help streamline that construction. And then also asset information. We want to know where all of our assets are, utilities and everything else on our system. That's just the way we have to do it so that we know what we're responsible for within our right-of-way. You know, Greg talked about it a little bit. You know, some of the risks are finding things in the field. Like I mentioned a second ago, it happens a lot. One example I have, a real-world example, is whenever we were developing a project off of I-35 for a side road. And what we did was put a traffic light at a certain intersection. Well, the SUE work there had not been done completely, and not until we went back out to the field after letting did we find that there was a high-pressure gas line, 18-inch gas line. Couldn't be more perfect where that drill shaft was going to be if we planned it. And so luckily we were able to find it. But could you imagine on I-35 in downtown Austin what kind of impact that would have had? So that's a risk, right? And that happens often. Change orders is another thing because of whenever we are doing our designs, sometimes we can't relocate whenever we're already in construction. If it's a gas line or something that requires a lot of coordination, we have to go ahead and just design around there in the field. Change orders are a big part of what our budget goes towards. That's something that we think digital delivery is going to help with, but with utilities being a part of this game like we're talking about, that does help that. And then time delays. Whenever you have to do anything in the field, it takes time. And that's something, like I mentioned, we have people exposed out to live traffic longer than we want to. We really want to try to expedite this the safest way we can, and by having these utilities in our contracts that are 3D and that can be incorporated into our design, it really does have that benefit. So, as Richard talked about, we do have the need to really exchange information between systems. We are a Bentley shop at TxDOT, and one of the things that we are working with is how do we make sure that we get that information in a readily available and usable format. For our soup providers, we want to make sure that we can get Bentley CAD files. We've requested those in the past. Those are something that we get frequently. Again, to their point earlier, with the new codes that are out there, those requirements that we have to be surveyed in, that's going to help a lot. Right now, it's just at our TAC depth, so we don't know exactly where those Z values are all the time. Shape files are also something we can consume. For the utility owners, it's good for them to be able to have all of these different types of shape files or PDFs or CSVs so that they can consume it as well. And then the database, when we worked with Richard and Greg on the development of this, we talked about being forward-thinking because, as they mentioned, we don't know where technology is going. Technology is moving so fast right now that in the next 5 years, we're going to probably have something that we didn't even know existed. So shape files was one of the things we knew we wanted to get in there because we feel GIS is a big component of digital delivery as we move forward. But also XMLs, and we wanted to forward think enough about IFCs. We know that the IFC is not developed enough yet in the utility realm, but it's getting there. And that's something that we, as an industry, we need to push towards because there is a lot of benefit for having that IFC within the IFC capabilities within all of the applications that we use. Flexibility is something that we've talked about a couple of times, and it really does mean that we're ever changing. The changing environments, the way that we do things. At TxDOT right now, we're trying to change the way, I like to say we're changing the way we do business fundamentally when we start talking about digital delivery. We have to keep that in mind when it comes to not only digital delivery, but how it relates to utilities as well. The communications with not only our stakeholders, but with the public, with other entities is very important. We have to make sure that we're flexible in that communication, be able to communicate with them what we're doing so that we have a common plan. And then lessons learned are something we're going to continue to learn on. We do have one pilot project, and I think my next slide shows a little bit about that one, that we have utilities on. And right now we did receive the utilities in 3D, and it's something that we feel is very advantageous for us. But as we go to construction, we're going to find out more about it. How good was that utility location? What do we need to do in the future to make sure that it's better? And how, as designers, can we work to overcome any sort of challenges we get out there with utilities or anything else? And then stakeholder communication is also very important. I mentioned that a second ago. I don't have it on twice, but it's very important for us to have that stakeholder communication. Lastly, there's big importance for us as we move to digital delivery and have these digital as-builts in the utility coordination process, right? So as we start shooting these relocated utilities in, we have to have this database, as they're talking about, for us to be able to know where they are for the next project. TxDOT is planning on being very open with the ability to share these files with people that need it, utility owners or contractors or any other entities that need it. And also, incorporating the as-builts that we have into the utility coordinating process. I think that's going to be something that's huge because as we start developing our 3D model of our utilities around the state, having those 3D models that we've designed or that we've constructed will be something that really does help with us locating them efficiently. And as you see on these two pictures that I have, I don't know if you can see them very well. I apologize that the background is not so great. But on the top one, we do see that we do have utilities that were located and delivered in 3D. And if you look below, that's our actual design on top of it, for us to see exactly where things are so that we can avoid things when necessary and to see how it all fits together. When we start talking about project development, there's all different aspects of it that we need to consider when we start talking even traditional or digital delivery. Utility coordination is a big part of that Construction is a big part of that. But really, the way we look at that is how they all marry together. How do we work together to make sure that the process that we develop and go through are as seamless as possible and the most efficient as possible? I think with that, we are done. We have some time for questions. So if anyone has questions, other than beyond what we talked about a minute ago. Yes, sir.
So to kind of extend the question I asked of Greg, you're taking their data for 3D utility subsurface, bringing them into your 3D model, rendering it out. Would you go to a public display with that and then mask out those critical utility infrastructure so somebody may see the end result of the design, but not where those underground utilities are?
I think we're exploring that. Greg, what do you think on that?
Yeah, I mean, if we include it, I feel like in the package, a customer could do an open records request
Right.
and obtain that information. So I think we have lots of partners in Texas that are, constantly telling us that their information is confidential and proprietary and we can't share it. But if you're located inside TxDOT right away by permit, the public has a right to know where you are. And I think that's kind of the stance that we'll take.
Just
I
a quick
agree.
follow-up on that. One of the thoughts, one of our utility staff had talked about, I'm at with Minnesota DOT, was could you do something like just change it to, it's a 3-foot diameter pipe. We don't know, we won't tell you who it is or what it is that owns it. We just know
Yeah.
we can't hit it.
And I think that would probably be the way that we would approach it. The owner of it isn't as important to the public as it is to us, right? And so them knowing where utilities are so they can see the challenges that we go through, I think is important. But them to know exactly, I think we'd probably have to be convinced that that's something that the public does need to know. Yes, sir.
Have you had contractors also, or inspectors also, show the limits of maybe a concrete cap that's over top that they trench, lay the utility and document the utility and then document the cap that's on top of it?
So I'll leave that to Greg. I don't know if we've done that, if that's something that in our SUE contracts to do that.
Yeah, we've had multiple situations, and the one that comes to mind is on a design build project where we had our contractor, coordinate with the utility company, and that was the solution that they came to, was a concrete cap, and we had that kind of built into the plans, and then we even built what the contractor did into the utility permit. So when we want to look years from now, hey, what does that concrete cap look like? We have that data.
Yes, sir.
One, I guess, idea or thought to this is that you would also see a benefit in contingency in bids, right? Contractors aren't going to carry the big contingencies if we de-risk utilities. Have you
Agreed.
seen any evidence of that? I mean, is it still too early?
So for us, it's too early to see that right now. We're only on our first pilot project. But from what we've heard from others, whenever you give a 3D file to somebody and say, within this level of reasonability, we have confidence in, on the utilities are here and this design is, fully complete and things like that, it does reduce that risk. They won't necessarily build in risk into their bids. Now, immediately they might, because it's a new way of consuming information, right? And so as we start getting past that learning curve, I think we will see that risk being bid into there less.
So one thing that we have seen is, when we have utilities that haven't been adjusted or railroad coordination that hasn't finished or right-of-way been purchased and we go after letting, we do what's called a construction management plan where we hard code dates into that plan saying, we're going to acquire that right-of-way by then, the utility's going to move by this date within this phase of the construction. And what we've seen is on those projects, higher bids than the projects that don't have construction management plans. So, I mean, I think kind of, kind of going to your question though, the more data that we give the contractors, like Jacob was saying, and the more they get used to it, then we hope that risk it's never going to be eliminated, but that it's reduced.
Right. Yeah. Whoever. You go. You. You. Minnesota.
Do you see with the use of 3D utilities, subsurface and that in the modeling process and the design impact, that you're able to issue relocate orders earlier in the business process? You don't have to wait till let in, or the 90%, you can start talking to utility owners earlier?
So we do, I think one of the biggest challenges is getting the design in a place where utilities are comfortable moving. And we continually preach to districts and preach to PS&E, engineers, like, set the design. Because we've got so many other things, I'm the deputy director of right-of-way division, so I also have right-of-way acquisition under my purview, and we have on projects when we're 90%, we need to go buy a little more right-of-way, and it's like, hey, no, no, and it's funny that the reputation gets to be, utility companies don't move. Well, we've lost their trust, in a lot of different times where we've said move. They go move, and then we change the design. So I think it's a mind shift change at the DOT to say, this is the design we're going forward with, this is what we're comfortable with, and supplying that to the utility company.
Well, and to add on to that, I think that, a lot of the reasons we change at the district level when I was in the district level, is that we don't really review things fully until 90%. Because there's so much other things. And so trying to really get a good review, a constructability review or anything like that on something that's on 2D is not easy to do. I mean, even for seasoned inspectors and things like that. And so if we're at 90%, we're like, well, how are we actually going to do this portion right here? We don't know. So that's where we have to redesign this. And they're frustrated with that, and 100%. I worked in utilities, I worked in design, so I can see both sides of it. But I think with us utilizing models and us being able to actually see conflicts, constructability, all these things like that, we'll be able to get that information to the utility people or whoever else needs it faster and more complete sooner.
So when you do these 3D models, and I know MicroStation or ROI, I think they use this
Clash detection.
clash detection tool that identifies. So a lot of times your conflicts are between the bottom of drainage structures. That's usually the problem issue. So you're detailing out all the bottoms of your drainage structures, and you're running that clash detection. Is that how you're doing it, or?
So from a 3D modeling perspective, we haven't gotten to that point yet. What is the level of development that we're going to do on all of our drainage structures like that? So we are still developing a lot of our cells for our drainage utility workspace. So that's something that we're going to look into to see what level of detail we have to go into those. There's the level of detail, just I'm sure y'all know, but it's how in the weeds do you get on a specific thing? Do we need to get that granular on something, or do we not? And so that's, I think, still what we're looking at doing to see how we can best utilize that clash detection tool.
I think class detection is where the conversation starts, right? And so in Texas, when I first started utility coordination, it was supply the plans to the utility company and you tell me if you're in conflict. That is now transferring with clash detection of DOT has control of the design. Yep. Hey, we're seeing it on our side that this could be a potential conflict. You disprove that it's not. And if you don't, go move it, and we'll work with you.
It gives us a little bit more teeth on that stuff because we have the ability to say, this is where you said you were. We have a conflict here. Like Greg said, show that it's not a conflict or we need to get moved.
Have you defined those bidirectional workflows from CAD to your GIS environment yet? And what does that look like for that utility content?
So, do you want to?
We're working on it.
Yeah, I think so. So, I think we're looking at a couple of things. FME is one of them. We are looking at Quadri to see if that can also be an effective tool for us to go from CAD to GIS. But like they said, we're working on it. We're trying to figure out what the best way to do it is.
So we have identified all of the data sets and the attributes that we want to exchange.
Yeah.
We just haven't done the physical exchange, and that's going to happen soon.
Okay.
Yes, sir.
I'm curious, when you're in a situation where you're in construction and you're exposing utilities, maybe not installing utilities, whose responsibility is it to say, locate a utility that's out there that might be different from what the as-built of that utility show? Do you have the inspectors go to look at, if you're trying to update a database of where everything is at, are you trying to jump on and update the database based on what you find in the field? And does that rely on the contractor or the inspector?
That's a good question, and probably one as Rulus matures that we'll need to look at how, if something is different in the field than what's in our system, how do we make those changes? I think right now we're just trying to get the information. I mean, we are so information hungry and have such a lack of information that we don't have that problem yet. But I think that's kind of the next layer of thinking is now we have the data. What is the integrity of that data? Does it match what's really in the field?
And I think I would just follow up too, like, once you have a database, right, like, you're supposed to collect it to that certain standard. But depending on who's collecting that information, who you put that onus on, is the designer on the next phase of the project for 10 years down the road, you know, or the DOT, how much do you trust that that information is collected correctly?
Well, I mean, an as-built at its core is level D information. I mean, the day after it's submitted, it's level D information. So I think that's how designers have to think moving forward on that next project 10 years down the line. We have an idea that a utility's here, let's go pothole it or, you know, do our one call, make sure that it's still there and the things that we have to do. We still have to do that quality check.
And I think those potholes will reduce as we start getting a full environment of our utilities that have been shot in. I think there will be less. It's more of a check than it is actually now for location purposes. Yes, Atton.
As a follow-up to Dash's question, so we have three sources of the data here, right? So SUs, utility owners, and the owner. One of the information is in GIS or CAD files, the others are in PDF or XML. So where I'm saying is like, isn't it kind of like a challenge that you don't have a single source of when
Yes.
three people are having three different
Yes.
data? So what's the how do I know that the utility owner is telling that I have this PDF, it says that it's here, but the CAD file that's with TxDOT is something else, or the SU owner is having, SU coordinator is having something else. Wouldn't it be easier for everybody to show that if it's in TxDOT right away, that we own the information, utility owner is going to provide us that information, but
Yes.
we own the XYZ. If anybody wants it, we have it. But like again, what Greg Lewis mentioned, it's still level D.
Right.
But at least it's going to give you a level of confidence that it's there, something is out there.
Correct.
Be careful.
Yeah.
Well, and one thing is third-party coordination, right? I mean, and that's the weakest link in the chain. And when you're depending on a utility company for that information, you know, it's either DOT, are you going to pay to go find this location? Are you going to pay to pothole that? Or are you going to take what the utility company says? So, I mean, that kind of plays into what you're saying a little bit. I mean, you got to think it's a third party, and there's no benefit to them really of obtaining this information. You know, yeah, hey, we might be able to avoid you in the future, but what they're worried about is the next project, the next release of technology, whatever. This isn't even on their radar. So,
Just wanted a couple points. A lot of the utility companies don't have that information. They're not keeping it. And so this does provide them some value being able to get that information out of the database itself. The other point is, even though it's record level data because it's in the past, if you have those attributes for location accuracy, there's value in that, knowing that somebody surveyed that in and that was the accuracy levels they used to survey her. So when you go back to reinvestigate, it's likely going to be in the very same spot or awfully close to it.
But one thing that we keep on TxDOT or any DOT will have to keep on reinforcing everybody is that it's the digital age. People should still, it's a moving ground. Like yesterday, it's a moving ground. You put the utility or something today, 5 years later, the ground has moved. Take it with a grain of salt.
Yeah.
In the vicinity, it's not like to the accuracy of like it's within this centimeters, within the centimeters. No.
Right. But I mean, it depends on also the geotech out there. It's not going to move, if it's in the solid rock, it's not going to move much, right? So,
yeah, if you're picking up an electronic depth, yeah, or something like that. So, well, I know it's 11:59, and I'm sure many of you
yeah,
are hungry.
We won't keep you off from lunch. Appreciate your time.